Okay, now these questions are a little bit trickier. We've got our two parabolas here, but the next question they ask for, which values of x is the product when you take the value, the f of x value, the y value of the function f times the y value of the function g, when are you going to get a negative number or zero? Well, you just think of it. It can't happen if you took a vertical line and you passed it through here. Here you'd have a negative value. Look, it's below zero. G is negative and f is negative, so it sure doesn't work here. Let's start over here, though. Here, f is positive to the left of d. And then this parabola keeps on going and going and going forever down here. The function g will be negative, and f will be positive. So it works anywhere to the left of d. And to do this question, you have to know that d is minus 3. This point A right here is 3 and 0, and B is 6 and 0. Now we know right anywhere to the left here is going to work. Let's take a look at these answers. Wherever they're on the opposite side, here and way down here, I can't see it on my graph, anywhere to the left of minus 3. So that's why this is your answer. X is less than or equal to minus 3. But here they're on the same side, here they're on the same side, but x equals 3 satisfies this thing. Remember, it says equals 0. And if you go greater than 6 here, this guy will be positive, way up over here. And these guys start going negative. They're on opposite sides of the x-axis. And I wish I had put in the little solutions. I'll put them in here. When you click on it, you'll see the intervals where this is true. But determine the average gradient. Gee, the line from B to C. Well, this one's pretty easy, because it's just figure out the gradient. C is 0 and minus 18. B is 6 and 0. So the gradient is just 0 minus 18 over 6 minus 0. That's 18 divided by 6. The gradient, the average gradient, the gradient is equal to 3. It's just another way of saying, what's the gradient between B and C? Wow, that was an easy one. Let's try the last one. Determine the values of k for which f of x equals k has non-real roots. Well, there's this technique that's pretty good. If you go f of x equals a number, like say way up here, say f of x equals 5. Then that would work, because if k was 5, that would be one thing that would be true, because see, it doesn't have any roots, no solutions at all. Anything above this point f, we've got to figure out this point f. So what do? We know that the axis of symmetry is 4.5. That's where f lies on. We just take 4.5 and put it in the function. And what do we get? 9 over 4. So that's our answer. As long as x, if it's equal to 9 over 4, it'll have one solution. But if it is greater than 9 over 4, there'll be non-real roots. There'll be no real roots. No real roots at all. Turns out their roots are imaginary. But that's it. There you go.